So the main goal of this one is we're going to basically optimize the hole patterns that you see here. So these holes here are driven by changes. Again, we want to make these changes in Creo. We don't want to make them on the other side in SpaceClaim. So we've got a sketch here which defines the diameter of the hole. We've also got dimensions down here. Now these other ones just are regular Creo names. So D16, for example. The ones I want to change, I actually rename. I call them DS something or other. The reason we do that is because Workbench has a kind of a handy filter that you can use. So the properties for my geometry, you'll see this thing called a parameter key. And what this does is it looks at all of the parameters that come from the CAD system. If they begin with ANS or DS, it keeps them. And if they don't, it gets rid of them. Right? So it's a nice way of filtering thousands of parameters down to just the ones that you want. So that's the reason I've called that DS, hole diameter. So I'm controlling that. And over here, I'm controlling two different things. One is the hole pitch. So that's DS hole pitch, you can see that. And then this one here is the number of extrusions that we are having in our pattern. So essentially the number of copies of this. This is copied sequentially as many times as we want. So here's the example in SpaceClaim. Again, it's opened up blocks for me. I should just say that these blocks, they're not exclusive to working with CAD parameters. At any time, you can record these blocks just by opening this window. For our purposes here, let's vary all three. So I'll take the pitch, I'll take the number of holes, and the diameter. And let's set this to 300. We'll set the hole pitch to 500, and maybe we'll take, let's say, 6 copies of that. So once again, as this goes out of date and I tell it to update, then the command is sent to Creo to say build again, right? So we're regenerating in Creo, importing this back into our system here in SpaceClaim. This is another candidate for mid-surfacing, so let's do that. So we'll pick out a couple of, I think this is probably our biggest gap to fill here. This is 40 millimeters. So again, when I go back to the Prepare tab, this will be an area where I would say mid-surface, use range, and I've forgotten what it was. I think it was 40. So let's say 45. We'll draw a box around here. Now, one thing it tries to do is after the mid-surface, it will try to extend. So you'll actually see a few successful extensions happen after the mid-surfacing occurs. So this is kind of the before, and as I click the mouse in the window here, you'll see our 2D shows up, and it has actually extended these automatically to meet up with the cylindrical face. Where it hasn't, it's probably because we've got partial intersections to think about. Or it could be some bigger gaps. So again, I'm just going to consider using extend once again. So this will be extensions, and I'll make a quick measurement while I'm here. It's a 24 millimeter gap, so that gives me the basis from which to start. So I'm going to say, let's call it 30, and I'll allow partial intersections to occur, which means, where you don't quite get this full overlap. If you turn on partial intersections, then it does allow it. If 30 looks like it doesn't close up all your gaps, you can try going a bit higher. So we've got a few extra ones nominated here. And for any ones that we can't automatically fix, well, then you can always use the standard SpaceClaim tools, right? So this move function, for example, I could take this face, say up to here. right? And we could do the same thing up at the top where we have this gap as well. So again, all of this stuff is recorded. Let's go ahead and fix this as well. Why not? So we'll nominate these 4 faces, and we will go up to here. Wherever you introduce potential gaps, you can always rerun extend, right? So the option is always there for the geometry to fix itself. And so following this, something that you will commonly do before you take this into Ansys Mechanical is you might want to split the faces where they meet up. You might want to have conformal meshing. And so the way we do that is we go to the Workbench tab and we click the Share option. So Share here has found a number of intersections. I can't see any that it's obviously missed, so I'll tell it to go. But if we did, you could change the tolerance there. And then, yeah, maybe as a final test after we've done those operations, we can try to verify if, let's say, these changes that we make right to the beginning of the model here can be reflected. And like I say, we've had some pretty good outcomes with this. So I mean, it seems to be robust to the types of things that you would commonly do. It's got all of my move operations. It's got all the trim operations taken care of. Things like share topology, split for symmetry. These are all kind of the things that we like to do and test, and these have been working well for us.